Is on proofs of these. I told you that these were coming. I will give you a set of things to look for, all right, in how to approach these questions, okay? But in the grand scheme of things, you can't have that beside you on the test. You can't have it beside you on the exam. So what is it that's going to take to get these through? You're going to have at least one or two of these on the provincial exam. So we have to do as many as we can. So basically speaking, you just have to work at these questions as much as you can. The more you see, the better off you're going to get at it. All right? So first question is 1 minus cos squared x is equal to sine x, cos x, tan x, right? Okay, now, the biggest thing is, number one, all right, if you look back, just flip back to 205 for a second, because it does give you some tips. The first, and just look at the tips. I'm not so worried about the guidelines, but the tips. It is easier to simplify a complicated expression than to make a simple expression more complicated. So start with the more complicated side of the identity. So I mentioned that the other day. You take the side that is the most complicated and try and simplify it. It's harder to take a simplified side and make it more complicated. All right? Use known identities to make substitutions. If a quadratic is present, consider the Pythagorean identity first. There's your first kind of rule / thing to look for. All right? So the number one thing is sine squared x plus cos squared x is equal to 1. If you have a quadratic inside of the equation, more than likely you're going to convert it using this guy. So if you wanted cos squared x, you would make it 1 minus sine squared x. If you want sine squared x, you make it 1 minus cos squared x. So there's your first one. The second thing is to change them all, if you can, if they're all single, change them all to sines and cos. Okay, because that's the simplest form of the expressions that you have. All right? Third, so now I'm going to get a little more in depth with you, and I'll add to this list after. Difference of squares. Four, factor. Okay. 5, another one. Common denominator. So there's about 2 more that I'm going to look at as we go through and we see example questions. But there's the five kind of indicators that you want to look for. Can I do something off this list? And that's what's going to help you make it simplified. Okay? So let's go back now. So I've got 1 minus cos squared x equals sine x, cos x, tan x. Either one of these sides. Now, again, I mentioned this to you day 1. You may simplify both sides. That's okay. But the fact is, you probably want to work exclusively on one side if at all possible. All right? Now, having said that, I'm going to work both sides of this guy. Okay? So first thing I do, remember, this is not an equality, it's an identity. And I need to verify it. So I do not put equals all the way down. At the start, at the very end. Okay? 1 minus cos squared x. Sine squared x. All right, so let's just leave this side as sine squared x. That's as simplified as we're going to get for that. Okay? So now, looking at the 5 rules, what would you suggest for this side? Or not the 5 rules, but the 5.
Okay, what is the second one? Sine x, cos x, what is that?
It means change them all to sine x or cos x. Okay. Exactly. So now I have sine x, right? Cos x. And again, I mentioned this before. I didn't do it on the first one here, but I'm going to do it here. if you make a substitution, put brackets around it. Remember, your goal is to show the indicators as to how you did the question. It's a 4-mark question. You need to show 4 marks worth of stuff. You can't just manipulate as you go and hope that they see what you did. So if you make a substitution using an identity of any sort, which we consider this a substitution of an identity, right? Then I put it in brackets. Okay? Question? All right.
Yeah.
And then what's sine x times sine x? Now I put my equals back in, and I set it equals the left-hand side. Okay? I just looked at the list of things. I don't know whose book I have here. Okay? 6. Formula sheet. That's for your identities. Now, when you do these identities with the sums and differences as well, you have to include them. Okay? They could be a part of this whole thing. So I just thought I'd throw that on there. Okay. Well, let's look at example 2 then. Example 2, 1 plus cos 2x over sine 2x is equal to cotan x. Okay. Complicated side, of course, probably the left side, right?
Cos 2x equals square root x.
Cos 2x and sine 2x. All right. So using our identities, I'm going to start with the bottom one because there's only one identity for it. Notice that this is a singular x, and these are double that x. So I need to get them all to singles. So I have to use my double angle identity to change it. So this guy changes to 2 sine x cos x. Just like that, right? Now I need to use one of the 3 identities. One of the 3 identities for cos 2x. Which one do you want to use and why? So look at your identities. This was on your formula sheet. You have 3 of them for cos 2x. Which one do you want to use?
Cos squared x minus sine squared x.
Okay, we could use cos squared x minus sine squared x, right? Now, if I do put that in here, I've got them to single to half their angles, which is what I want, right? But it makes it a little more difficult to work with it. But actually, you know what? I'll show you this. I wouldn't use this one, but I'm going to show you how to finish this one. Okay? So what is it? Cos squared x minus sine squared x? Or
Yeah.
sine-
Yeah, that looks right.
Okay, so I've got cos squared x minus sine squared x. Don't write this down. So there it is like this. But here's the thing. I have to somehow do some canceling. In the form I've got it right here, I can't cancel very easily. What is the thing that is holding me back from canceling at top with the bottom? It's this 1 right here. All right? If you look at it up here, this 1 makes it difficult because it actually is 2 separate fractions, right? Okay, that's 1 over sine 2x plus cos 2x over sine 2x. So that's actually 2 separate fractions, so that makes it tough. But if I look, go ahead.
There's one here that says cos 2x is equal to 2 cos squared
Yeah,
x minus.
I'm coming back to that. Let's finish with your guy right here first. Okay, that's exactly the one I would have used, and I'll tell you why in a second. But 1. What equals 1 off of your identity sheet?
Sine squared x plus cos squared x.
Sine squared x plus cos squared x. So if I put that in here, plus cos squared x minus sine squared x, right? And all that is over 2 sine x cos x. Okay? Cos squared x plus cos squared x is what? 2 cos squared x. Sine squared x subtract sine squared x is?
1,
It's what?
0.
Okay? So if that's sine squared minus sine squared is 0, that leaves me with this right here. Agreed? 2 divided by 2. Cos squared x over cos x. What am I left with? Cos x over sine x, which is done. Equals right hand side. Okay. So, your way worked just fine. But probably 3 extra steps. Okay? Nothing wrong with that. But here was the tough part. When you have a 1 like this, it's hard to look at it and say, hey, wait a minute, that's actually sine squared plus cos squared. So that's the tough part on this. So how would I have done this question slightly different? So I got 1 plus cos 2x over sine 2x, right? Equals cotan x. So go back to the last one that you said you would use.
Cos 2x equals 2 cos squared x minus 1.
Not 2 cos squared.
2 cos squared x.
Minus
Is
1.
that not what I said?
No, you said cos 2x.
Oh, sorry, my
Yeah.
bad. Sorry, so
Yeah. No, I think you understood what we're doing here. So we got that, right? And then that's 2 sine x cos x, right? So I like this one better, Cody, because that 1 subtract that 1 is 0. Cancels. So what am I left with? 2 cos squared x over this. Cancels. Cancels. What do I have? So 2 less steps there. Now, the beauty of it, okay, is you are allowed to use all 3, and all 3 will get you the correct way of doing it. But when you have a 1 like this, you want to do the one that's going to be subtract 1. So if it's a plus 1, I use this one. If it's a subtract 1, I use the 1 minus 2 sine squared x. Because then that gets rid of the 1s. But again, you don't know this because you haven't worked with this enough. So it's hard. That's what the difficult part is. You had a question, Carl.
Well, I was just wondering why you wouldn't use the other one, like why it'd be hard, but now I see.
Okay, so yeah. So I could use the other one. And then it would have given me 2 plus 2 sine squared x. And I would have had to take a 2 out, which would have, or 1 minus, it would have left me 2 minus sine squared x. And then I would have to factor and factor again and change it. So it would have been 2 more steps again. Okay? All right. So, again, not easy. Now let's look at this next one. Cos theta over 1 minus sine theta plus cos theta over 1 plus sine theta. Is that right? Equals 2 over cos theta. Okay. So look at your list on there. Look at the list of 6 or 7 things that I gave you want to look for. What do you suggest? Well, first of all, which side's more complicated? Probably the left-hand side, right? You agree? Okay. So I have 2 fractions here. So what do you suggest first? Common denominator. What is my common denominator? Excellent work. Absolutely. Okay, so I have cos theta here, and that'll be times 1 plus sine theta. Add cos theta here times 1 minus sine theta. And all of that is over 1 minus sine theta, 1 plus sine theta. Just like that, right? Okay, just got a common denominator. The common denominator is this times this. So what's this guy missing? Missing 1 plus sine theta. What's this guy missing? 1 minus sine theta. So again, one step off that chart, off that list of steps that I gave you, right? So now we got to simplify here. So now I'm going to have cos theta plus sine theta cos theta add cos theta subtract sine theta cos theta all over, what's 1 minus sine theta times 1 plus sine theta? When you multiply them together, what do you get? Pardon me? Not quite.
Plus sine squared x.
What do you got?
One plus sine squared theta.
Plus? Which one is it? A minus B, A plus B, A squared minus B squared. What did we just talk about? Difference of squares. Right? 1 minus sine squared theta. Okay, so now I'm looking at this right now. In the form that it's in. Right? Cos theta and cos theta make what? Two cos theta, correct? Put your pencils down. Watch this. Cos theta and cos theta make 2 cos theta. Sine theta cos theta minus sine theta cos theta is what? 0. So what is 1 minus sine squared theta? Very good. Cos squared theta. So what am I left with? Excuse me. What did I use? Both those on your list? Yep. Okay. Questions? One more. And you're off and running. Cos 4x minus sine 4x, is that right? And what does it equal? What does it equal, sir? Cos 2x. Okay, which is the more complicated side? Left. Okay, what am I looking at here? What's the first thing I should do with that?
Difference of squares.
Difference of squares, sure. So this becomes cos squared x minus sine squared x, right? Times cos squared x plus sine squared x. Is that right? Okay so far? Difference of squares. How do I simplify this now? Cos squared plus sine squared is 1. So what am I left with? Cos squared minus sine squared x, which is I'm done. One step. You had to identify Pythagorean identity after you did difference of squares. Okay? Like I said, this is going to be the most difficult thing you're going to work with. And the only way you get good at it is to do as many as you can. And they break it down in steps here for you. So they ask you, in the first part, they're asking you to simplify by factoring. The second part, it says factor to help prove. The third part says use a common denominator. So they're just building you up. Okay, they're showing you the small steps that are going to go into doing a major guy like this. Okay? You need to work on page 208, 209 right now, and 210. That is your work today, not what you were working on before. That should have been done. You need to work on this today. Okay? We are going to hit maximum speed here right away.